Sabi Africa, no Africa, no Africans, pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
The science behind traditional pottery glazes and kiln engineering. Do you know that every traditional pot you have ever seen carries the fingerprints of chemistry, physics, and centuries of engineering? Today, we are stepping into the world of African pottery, where local clays, plant ash, and handmade kilns formed a complete material science ecosystem long before the word material science existed. Clay is not just earth. It is a mix of alumina, silica, and trace minerals that behave like a composite when shaped and fired. As the pot dries, its microstructure shifts from a plastic network to a rigid, crystalline matrix. This is where artisans and scientists meet. Both rely on the predictable way clay particles align, shrink, and lock together under heat. A glaze is basically engineered glass. It forms when silica, alumina, and fluxing minerals melt and fuse onto the clay body. Traditional potters achieve this using materials around them like wood ash, feldspar-bearing stones, river sand, and iron-rich soils. The blend controls melt temperature, color, texture, and durability. The artistry lies in understanding how these ingredients behave when the heat rises. Across West and Central Africa, artisans turn everyday byproducts into glaze chemistry. Palm kernel shell ash, for instance, holds silica, calcium, and iron, which are perfect for making natural fluxes and earthy glazes. These choices were not random. They evolved from careful observation of how local minerals react in fire, proving that indigenous knowledge is both scientific and sustainable. Color in pottery is not paint, it is chemistry. Iron oxides shift from yellow to red to deep brown depending on heat and oxygen. Copper can turn green in an oxidizing flame or red in a reducing one. Traditional firing techniques control how air moves through the kiln, and that airflow decides the final shade. What you see on the surface is the result of changing oxidation states at over 1,000 degrees. A kiln is more than a furnace. It is a controlled reactor where heat flow, draft, and atmosphere all shape the pot's final properties. Updraft kilns, downdraft kilns, clamp kilns, and pit kilns each create different thermal environments. African villages engineered these systems with available materials like clay bricks, laterite soil, termite mounds, building hot zones, and pathways that rival modern thermodynamics. The way a kiln heats up matters as much as the final temperature. A slow climb lets gases escape from the glaze. A long soak creates stronger bonds in the clay body. Too fast and the pot blisters. Too slow and the glaze can crystallize. Traditional potters learn these curves by watching the color of the flame, listening to the sound of the fire, and reading the glow of the chamber itself. Long before energy efficiency became an engineering goal, African kiln builders had already mastered it. Modified clamp kilns reuse exhaust heat. Downdraft designs circulate hot gases back through the load. And the fuels, which are dry agricultural residues, lightweight woods, and biomass, keep firing cycles clean and affordable. These are practical solutions rooted in place, not theory. Today, researchers are revisiting what artisans have always known: waste streams can become valuable materials. Plant ash, rice husk ash, fly ash from industries, and broken pots from previous firings all work as raw materials for glaze formulation. When tested and refined, these locally sourced oxides match or outperform commercial imports. It is a circular design born from tradition, now supported by lab science. When you look at a handmade pot, you are seeing physics, chemistry, engineering, and cultural memory fused into one object. The future of sustainable ceramics, whether in Africa or anywhere else, will grow stronger by studying this indigenous science. Traditional knowledge is not just heritage, it is a blueprint for ethical, low-impact, high-performance materials, and the world is finally catching up.